this case study, Arconic worked with Moldex 3D in Italy to demonstrate the advantages of using QC-10 over P20 steel for an automotive injection moulded part. All of the material attributes of QC-10 are built into Moldex 3D simulation software. Later in the presentation, there are some examples where QC-10 and P20 performance have also been compared with physical moulds. 4 key physical properties were considered when comparing P20 with QC-10. These are density. The density of aluminium is about 35% that of steel. That means that the tools are lighter and easier to handle. Young's modulus. The modulus of steel is about 65% greater than that of aluminium. That means that, in general, aluminium mould blocks need to be thicker to compensate. Coefficient of linear thermal expansion. In steel, the coefficient is 50% less than in aluminium, which means that aluminium moulds may need to be dimensioned to account for this. And perhaps most significant is thermal conductivity. The thermal conductivity of QC-10 is over 4 times higher than that of P20 steel. This means that you'll get a more efficient and more uniform heat transfer rate during the moulding cycle. The part modelled in Moldex 3D was an automotive bumper measuring almost 1.8 metres wide by 600 millimetres in length. A conventional cooling channel arrangement was adopted on either half of the mould cavity. What it used was polypropylene, and the key process parameters adopted are as shown. What is important to note is that for this exercise, exactly the same design, model and same process parameters were used to give a direct comparison between P20 steel and QC-10. In reality, the QC-10 mould could be designed more optimally for the aluminium. Running the Moldex 3D simulation, the following results were obtained. Based on overall part deformation, Moldex 3D calculated that there would be less warpage in the part produced using QC-10, by up to 11%. Taking note of the scales, you can see from the animation where the deformation will be greater in the part produced from the P20 mould. In terms of volumetric shrinkage, the QC-10 part actually showed less shrinkage compared to the P20 part. A reduction of about 1% from 7 to 6 may not seem very significant, but, as we know, deformation and warpage occur when the plastic shrinks. This can cause the walls of a mould to be pulled inwards, leading to high localised internal stresses in the mould and distortion in the part. It is widely thought within the industry that it is naturally worse in aluminium than in steel,